activity. Here we have a recipe for s'mores, and we have the ingredients laid out. We're going to start, and we're going to see how many we have of each one. We have 6 chocolate bars. I counted, we have 24 graham crackers, and I counted 48 marshmallows in the bag. So, according to this recipe, we need 1 graham cracker, a half a chocolate bar, and 1 marshmallow for each s'more. So we're going to see how many we can make. I want you to think about it while we put them together. So you can see we have 12 s'mores made from the ingredients we have. We have some graham crackers left over and some marshmallows. So our recipe with our ingredients we had yielded 12 s'mores. Okay, today's lesson is about percent yield. We're going to use our formula here, need minus half divided by need times 100 will give us our percent yield. We got our need numbers from our recipe. We subtracted what we have on hand and divide that by what we needed from the recipe times 100 to give us our percent yield. So in chemistry terms, that would be our theoretical yield, what we should get from our formulas, minus what we actually got from the experiment, divided by our theoretical, again, times 100 we get our percent yield from our laboratory experiment.
Alright guys, the other concept we're talking about this week is called limiting and excess. So what limited how many s'mores we could make? Well, basically, what did we run out of? So we actually ran out of chocolate bars, which limited our ability to make more s'mores. So all the chocolate bars were gone, but we did have extra, so we had limiting our chocolate bars, so we used all 6 bars, or 12 halves if you remember the recipe. And then we had extra or excess of our graham crackers and our marshmallows. And specifically, you can figure out how many by subtracting. So we started out with 24 graham crackers. We used up 12 in total for our recipe, for our yield, which was 12. And we ended up with 12 left over, right? And then for marshmallows, we had 48 to start with. Each s'more needed 1 marshmallow. So 48 minus 12 would give you 36 left over. So that's how much excess we have extra of. And this is relevant for everyday life. Businesses have to do this all the time because they have some ingredient that they run out of and then usually have extra of. And usually the thing that's more expensive is what is limiting them. And the cheaper ingredients are usually what they have extra of, like water, for example. So a lot of industries do this when they're making a lot of the products that you guys use every day.
From our ingredients, we're going to figure out what percent each of them would yield. So we had 6 chocolate bars, and each s'more needed a half a chocolate bar. So we're going to cancel out our units like we did in dimensional analysis at the beginning of the year. So we're going to cancel out our chocolate bars because chocolate bars divided by chocolate bars cancel each other out, leaving us with a s'more unit. So then we're going to take our numbers. 6 times 1 is 6. 6 divided by 1/2. 6 divided by 1/2 will give us 12 s'mores. Alright. And then we also started with 24 graham crackers. So our recipe said 1 graham cracker for every 1 s'more, so that's a 1-to-1 ratio. 24 times 1 divided by 1 is going to give us 24 s'mores. Okay? And our marshmallows, we have 48. Again, for one s'more, we needed one marshmallow. So that's 48 times 1 divided by 1 is going to give us 48. Okay, so we look at how many s'mores we actually had. Whoops, my s'mores are falling apart. We did come up with 12 s'mores from our 6 chocolate bars. We used all of our chocolate bars. So that was a 100% yield from our chocolate bars. Okay. We started with 24 graham crackers, which said we could make 24 s'mores. But we didn't make 24 s'mores. We only made 12. Okay, so we did not have 100% yield on our graham crackers. We had some excess left over. And 48 marshmallows. We didn't make 48 s'mores, so we had 36 marshmallows left over, so that's not 100% of our marshmallows used. So we're going to look at how we can figure out our limiting and our so we were limited by how many chocolate bars. So we're going to figure out what percent yield we had from our graham crackers and our marshmallows next.
Alright guys, so the next part of our video, I'm going to clarify just a couple things and then go through a little bit of the math that you're going to be doing. So just to make clear, the word yield comes from, you see it when you ever make recipes at home, especially baking, like cookies. So it'll say this recipe yields 2 dozen cookies. Well, dozen means 12, right? So that means you get 2 dozen or 24 cookies. So you just want to make sure that you guys understand where that word's coming from. You've also seen it in previous weeks in the arrow of a reaction and how it shows how much that's yielding or making or producing. All right. So if you look at the math here, so remember the formula we saw. We took what we have minus what we used divided by what we had times 100. So this is what it looks like in practice. And we actually will take the absolute value, that's these two here. All that means is you cannot get a negative number. There's no such thing as negative percents here, okay? And don't forget, all percentages add up to 100, right? That's just kind of how percents work. So when we take a look at our recipe that we did, if you take that fact that we had 24 graham crackers available, that's what we had to use. We only used up 12 of them, so we subtract that, 24 minus 12. Absolute value, just keep it 12, keep it positive. Divide by the 24, remember that was what we had. Okay, so 12 divided by 24 is basically a half. So you translate that into percent by multiplying, you would get 50%. So we had 50% yield of our graham crackers. So that means we also had 50% left over. If you recall, that was one of our excess ingredients or reactants. Okay, so if you go to the marshmallows, let's see what happened here. We started out with 48 marshmallows available. We only used up 12. Okay, so remember 48 minus 12 was 36, keeping it positive because of the absolute value. Divide by the 48 that you had available, and then times that by 100, you get 25% yield. Because that's 36 over 48 is about a fourth, right, as a fraction, times 100, and that would give you 25. So that means that 75%, if you subtract from 100, you're left with 75. That was excess. Right? So you had 75% of what you started with you had left over, so that was quite a bit. Now, I'm not showing you the calculation for the graham crackers because you can figure it out. Remember, that's what limited us to only being able to make or yield 12 s'mores. So 100%, I'm sorry, I said graham crackers, the chocolate. The chocolate was our limiting, and that's the thing that made us only be able to do 12. So that was 100% used, right? 100% of our chocolate was gone. So that's easy to say, oh, 100% yield, all right? So what we've discussed today is basically percent yield, taking your have minus used over what you had, or basically your what does it have?
Theoretical.
Theoretical minus actual over theoretical is the chemistry way of saying it. Times 100. You always end up with the percentages. They have to be in percentages. You have to, don't forget to times 100, and that's your percent yield, how much you make. And we also talked about what limits you in making recipes and how much you have left over, which is called excess, but you can just subtract for that. Yes, times 100. That's a key factor, because that is one big mistake that people always make, and they will get 0.25 as their answer, and that's not right, or 0.5, and that's not right. So then if you try to subtract also to find your excess, you'll get numbers really, really far off. And those are our concepts, percent yield and limiting and excess. Good luck, guys.